Today is going to be 33-5, and we're going to look at half-angle identities. So we're going to use half-angle identities to evaluate and find trig ratios and verify proofs with those half-angle identities. So these are the half-angle identities, and they apply for all angles of theta. Now just remember the plus or minus depends on the quadrant in which the terminal side of theta over 2 lies. Okay, so that's important. The plus or minus is where the terminal side of theta over 2 lies. So we have to think in respective to where it's supposed to be. So this first one says use the half angle formula to find the exact value of cosine of 15 degrees. Well, I know this is my cosine ratio, and so I need to write it as theta over 2. So I'm going to say the cosine of theta over 2. So now that it's in that form, I can use the identity. Now this is in quadrant 1, so I know its cosine is normally positive. So I'm going to get the positive square root of 1 plus cosine of 30 degrees all over 2. And so that's going to be the square root of 1 plus radical 3 over 2 all over 2. And then finding the common denominator between all of that stuff, we're going to get, that's 2 over 2 plus radical 3 over 2. And then I can add those together. And so that's going to be the square root of 2 plus radical 3 over 4, which is the square root of 2 plus radical 3 all over 2. I know it's kind of weird, a square root within a square root. That's just the notation. So the first thing that I did is I wrote my statement into theta over 2, so we don't have the cosine of 15 degrees. So I need to think, how can I write 15 degrees in terms of values on the unit circle? Well, 30 degrees. So that's why I wrote it as 30 over 2. And then I just used the identity. We said theta is 30, and so I plugged in 30 degrees in the identity, which is what I did here, and I simplified to get my result. Next one, it says suppose negative pi is less than or equal to theta, which is less than or equal to 0. Okay, so this is telling me that my angle is between negative pi and 0. Okay, so that's a wide range. So that's going to literally be in this axis down here. And with cosine of theta equaling negative 3 pi halves. Find sine of theta over 2. So going through this, I know that it could either be in quadrant number 3 or quadrant number 4 because of this. And then my cosine is also negative, so it's going to have to be in this quadrant. But remember, it says sine of theta over 2, so that half angle, it might affect what my statement is going to be. So we at least need to start just by drawing this triangle. So it's going to be adjacent over hypotenuse. And so the Pythagorean theorem, I know that's going to be a negative 4. So my sine theta, we know that sine on both of these quadrants is negative. So the sine of theta over 2 is going to be negative 1 minus, now the cosine of theta is going to be negative 3/5 all over 2, because the cosine of theta here is going to be adjacent over hypotenuse. I know it's the same thing. You're right, because that's where the triangle is in that quadrant. And so this is going to be the negative square root 1 plus 3/5 all over 2, 5 over 5, so that's going to become 8 over 10, the square root of that. And you can reduce that into, 4/10 or 4/5, which is then going to be -2 over root 5. I know there's a square root in the denominator. That's okay. We can just leave it as that. Kind of unpacking this again though. Remember, this has given us a larger range because of this whole half angle identity. It's like, how is this going to fit in that? That's the only reason why it's like that. But just know that my entire sine, no matter what, is going to be negative in there. And so my cosine being -3/5. So I drew my triangle there. That's how I was doing adjacent over hypotenuse. That's what I did here. And so my sine of theta over 2 equals 1 minus my cosine theta. Well, we said cosine theta is -3/5, which is why I plug it in there, divide all that by 2, and then I just simplified it in some fashion. Let's look at another one. So the first step, write the statement into theta over 2. So I would write that as sine of 210 over 2, because I know what 210 is inside the unit circle. And then I would use the identity. I know that sine in this quadrant is going to be positive, so that's going to be the positive square root of 1 minus cosine of 210 all over 2, and then you'd have to go through and simplify that. Let's look at an identity here. So it's asking us to simplify cosecant of 2x minus cotangent of 2x. Now, if I were to take this tangent of theta and simplify it further, it also simplifies into that statement there. So tangent of theta over 2 will also simplify into that statement. So in trying to simplify this, I can turn this into 1 over sine of 2x minus, this looks like cosine of 2x over sine of 2x. So those combine together into 1 minus cosine of 2x over sine of 2x. Now this looks really familiar to this. Okay, that's actually the identity for it. And so it's going to be the tangent of, now my theta is 2x, so 2x over 2. Those cancel out, so I just get tangent x, and that is going to be my answer. So closing today's lesson, what did we learn today? Well, we talked about half angle identities and how to use them in both just evaluating and being able to use it a little bit more analytically in terms of where it is on the coordinate plane. And what are the half angle identities? So I want to hear from you. Go ahead and give me feedback on what the half angle identities are. This does conclude our lesson. If you have any other questions, please leave them in the comments.